Hello, so this is a revision video for IB Chemistry S1.1.1, Elements, Compounds and Mixtures. This is a revision video, so we just go through the essentials that you need to know. For more detailed explanations and video lessons, please check the links in the description below and visit chemistrystudent.com. Elements are substances made up of only one type of atom. For example, if you take a piece of magnesium metal, inside it you will just find lots and lots of magnesium atoms. They cannot be chemically broken down into simpler substances, and all atoms in an element have the same number of protons, meaning they share the same atomic number. They can be represented by chemical symbols. A compound is a substance made when atoms of two or more different elements are chemically bonded together. For example, water, which has a formula of H2O, is a compound made up of oxygen and hydrogen atoms. The atoms are in a fixed whole number ratio and can only be separated into elements by chemical reactions. The properties of a compound are different from those of the elements it contains. A mixture is a physical combination of two or more substances that can be elements or compounds that aren't chemically bonded together. The substances within a mixture retain their original properties, even if the mixture itself shows a different property to the substances it contains. The composition of mixtures can vary as there is no fixed ratio, and they can be separated by physical methods. There are two main types of mixtures, homogeneous and heterogeneous. Homogeneous mixtures have a uniform composition throughout. They're also called solutions. The individual components aren't visible and they are completely mixed together. For example, water and ethanol mixed together create a homogeneous mixture, where the water and ethanol molecules mix completely together to create a uniform solution. Heterogeneous mixtures have a non-uniform composition. This means the different components are visible or can settle out. For example, water and grease or oil form a heterogeneous mixture because the substances within it, the water and grease molecules, are unable to mix and so separate and form two distinct layers. Because mixtures are made up of substances only physically held together rather than by chemical bonds, they can be separated using physical separation methods. You need to know the following methods of separation: filtration, evaporation, distillation, recrystallization, paper chromatography, and solvation. Filtration is used to separate an insoluble solid from a liquid. A filter paper allows the liquid to pass through while the solid particles remain as a residue. The liquid collected is called a filtrate. Evaporation is a technique used to remove a solvent from a solution, leaving the solute behind. The solvent evaporates and the solute particles stick together and crystallize, forming a solid. Distillation separates components in a mixture based on their different boiling points. Simple distillation is used to separate a solvent from a solution, for example, collecting water from ink. Fractional distillation separates mixtures of lots of different liquids with boiling points that are close together. Recrystallization is where we can purify a solid compound from a mixture of impurities. We dissolve the impure solid in a hot solvent and then cool it slowly. The desired compound will crystallize out as its solubility decreases in the solvent, but the impurities remain dissolved in the solution, meaning we end up with the solid desired compound, but the impurities remain in the solution. Paper chromatography separates substances based on their solubility in a solvent and affinity for the paper that's used, the stationary phase. The components in the mixture move at different speeds up the paper and separate into distinct spots. Substances in the mixture that are more soluble in the solvent will travel a higher distance up the plate in the same length of time, and substances that are less soluble in the solvent will travel less distance up the plate. Solvation is where we take a solid and dissolve it in a solvent to form a solution. Usually this is used to remove impurities, because if a solid contains impurities that won't dissolve in the solvent, as you add the solvent to the sample, the desired compound will dissolve and form a solution, leaving behind the insoluble impurities that you can remove by filtration. Then you can use evaporation to remove the solvent from your solution to end up with the pure substance.